Hi, class. Hi, everyone. Welcome back to our distant learning course, video series number 4 on chapter 12, selecting a sample. So in this lesson, we are going to learn 3 principles of sampling. You can refer to pages 231 to 233 in our textbook. First, we go to the first principle of sampling in quantitative studies. Suppose or imagine there are 4 individuals in your population. The population is very small. We take this as an example. Mr. A, Mr. B, Miss C, and Mrs. D. So A is 18 years old, B 20 years old, C 23 years old, and D 25 years old. So we are going to, here we compute the average age of the population. So how do we do that? Yes, very good, you are so smart. So 18 plus 20 plus 23 plus 25 split by 4, the size of the population, and the average age of our population is 21.5 years. So now let's practice some principle of sampling. We want to choose a sample of 2 individuals. Why do we do that? Because we want to make a prediction. We want to make an estimate of the population age. You might ask me a question, why making an estimate of the population age when we already know the population age? That is a very smart question. That is a $1 million question. And the answer is, in real life, in true research, we never know, the population characteristics such as income or age, or average number of books that they read per year. We don't know that. We never know that. That is why we rely on statistics or research results that come from a small population. So we're gonna come back to our lesson here. So we're gonna randomly select all possible pairs. You remember simple random sampling. We select all possible pairs of 2 individuals. So the first sample is A and B. So the average age of this sample is 19 years old. A and C, the second sample, 20.5 years. Sample 3 produces an average age of 21.5. Sample 4 results in an average age of 21.5, exactly the same. Sample 5 consisting of B and D, the average age is 22.5, and the last one, C and D, average age is 24 years old. So we end up having 6 possible pairs if we do random sampling in order to select our samples of 2 individuals. So you can see the population average age in our research is 21.5 years old. Now you can compare the average age years produced by our 6 samples and the true population average age. So the first sample produces a different result. The second sample also produces the different result. Only samples 3 and 4 produce the average ages that are exactly the same as the population average age. Unfortunately, samples 5 and 6 also produce different, results. So that comes, ladies and gentlemen, principle number 1. Principle number 1 was born based on this scenario, this demonstration. In a majority of cases where sampling is done, there will be a difference between the sample statistics and the true population mean, which is attributable to the selection of the units in the sample known as sampling error. So you can see only two cases or only two samples that produce the same results as the population average age. Four samples or four cases, or in this case, a majority of cases, produce sample statistics that are different from the population parameter or the population mean. That is principle number one. In other words, please take away this concept, sampling error. Every time we rely on a sample in order to estimate or generalize the result to the bigger population, there's gonna be sampling error. It's impossible that it's almost impossible that we're gonna produce exactly the same results as the population. That's principle number one. So before we go to the next principle, the range, the first sample produces a younger age, 2.5 years old, years younger, and the last sample produces an older, age, 2.5 years older in this instance. So that's it, principle number one. Let's move on to principle number two. Now let's choose a sample of 3. We increase, the sample size. We make it a little bit bigger from a sample of 2 to a sample of 3 in order to do the same jobs, in order to make an estimate of the population mean age. So we're going to randomly select all possible pairs again. The first pair, ABC, 20.33 years. ABD, 21 years. ACD, 22 years old. And the last one, BCD, 22.67 years. And if you compare these average ages to the population average age, still different, okay? Still different ages. They are still different, but the difference gets so small right now, gets smaller. So that comes to the birthday of principle number 2. The greater the sample size, the more accurate the estimate of the true population mean. So when you increase a sample size from 2 to a sample size of 3, the estimates of the population mean is more accurate, as in this instance. So now the range, gets so small if you compare to the previous example. The difference is just plus minus 1.17 years old, whereas the first instance produces sample statistics that is plus minus 2.5 years different. So that is principle number 2, everyone. Let's move to the last principle. Let us take a different example now. The same size of the population, a population of 4, for our demonstration, for our illustration, but age or this demographic of age is so heterogeneous, is so varied, is so diverse. A is 18 years old, B is 26 years old, C is 32 years old, and D is 40 years old. So in research, this is called diversity. This is called heterogeneity of the variable of interest to your study. So we're gonna randomly select again all possible pairs as the first two principles, sample of 2 and sample of 3. And we go to the quick results here. With a sample of 2, you can see the population average age is 29. How do we get 29, everyone? Yes, very simple. 18 plus 26 plus 32 plus 40 and split by 4. So the average age of the population is 29. So with a sample of 2, we're gonna end up having 6 pairs also as in the previous example. But the difference is so diverse right now. It's so different. The first sample produces an average age that is 7 years younger. The last sample, sample 6, produces a sample statistic that is 7 years older. So the error is big in this situation. Why so big? Easy answer. Very easy answer. Because the variable age in this example, in this population, is so heterogeneous, is so diverse. And if you go to a sample of 3, with a sample of 3, you increase from 2 to 3, the error is, the margin of error gets smaller right now, minus and plus 3.67. So it gets better. That makes sense, right, everyone? That makes sense. A bigger sample size is better than a smaller sample size. That's common sense. That's mathematics. That's statistic. Okay. Now we go to the principle. Last principle, principle 3. The greater the difference in the variable under study in a population, for a given sample size, the greater the difference between the sample statistics and the true population mean. This is so true. This is so true in this example. That's it, everyone. And we are done with this video clip for chapter 12. And I shall see you next time. Thank you very much.